Problem 4 here asks you about a grain terminal dumping grain into a freight car. Um, it's dumped straight down, so the grain does not carry with it any momentum in X. Let's draw a little cartoon of what's going on. So I keep palming my touch screen. Before, I have some railroad car with some mass moving at some initial speed of 4.4 meters per second. And actually, let me draw this over here. Because I also need to draw the pile of grain that's being dropped into it straight down. And then after, I have my freight car loaded with a big pile of grain. And we'll say that this has a mass big M. And after, this is moving at some final velocity, which is 3 meters per second. So this is a collision. So this suggests that we use conservation of momentum. And we're helped out by recognizing there is no external force in X. There is in Y. There's a railroad track down here, right? So there are normal forces and gravity and stuff, but we don't care because we're just going to use conservation of momentum in X. And the Vx of the grain is 0. So I have initial momentum equals final momentum, sums for both. The initial momentum is just the momentum of the train car. And the final momentum is the train car plus the grain times V final. So here we know everything but the mass of the grain. That's what we're going to be solving for. So if I distribute out the right side, I have mvf plus big M Vf. Solving this for big M, this gives us that big M is little mv naught minus little m Vf, all divided by, let's see, put that over there, divided by big M. Whoops, did I mess something up? You know, I'm going to stop skipping steps in the algebra. I'm just going to do it right. mv naught equals little m Vf plus big M Vf. We want to solve for big M. Vf was in the denominator. This is why I shouldn't skip steps. So this gives me mv naught minus mvf over Vf equals big M. So that's the solution symbolically. Oops. So now if I put these numbers in, so 4.4 and 3.0 are going to be hard to do in my head. So let's just type this into Google Calculator. So I have 2,000 kilograms times initial velocity of 4.4 meters per second minus 2,000 kilograms times 3.0 meters per second. All of this divided by 3.0 meters per second. And I get that m is 933 kilograms. So this problem was just straightforward conservation of momentum in one dimension.